Hello everyone, welcome to Garan Gurukul and this is Yogesh Kark. So in this video we are going to discuss JEE Advanced 2018 Paper 1 question number 10, and this question is based on inverse trigonometry and geometric progression as well. So what we have, the number of real solutions of this equation, sine inverse of, you have something in bracket, right, is equal to pi by 2 minus cos inverse of something in again in bracket, lying in the interval minus half to half. So it is quite comfortable. What we have to see, that whatsoever we have inside of sine inverse and whatsoever we have inside of cos inverse, it should be between minus 1 and 1, right? Here the inverse trigonometric functions sine inverse x and cos inverse x assume value in minus pi by 2 to pi by 2 and 0 to pi. We all know this, right? So fine. Now what we have to see, it's very interesting thing over here. What should be true? See, we have this identity that sine inverse of x plus cos inverse of x is equal to pi by 2, right? We have this identity. We should use the logic of this particular identity. It means that, let us say this is some y, right? You have something, sine inverse of something plus cos inverse of something is equal to pi by 2. Because that something should be same, isn't it? This what you have in bracket inside of this and what you have inside of bracket inside of this, they should be same. It means that sigma I is equal to 1 to infinity x I plus 1 minus x into sigma I is equal to 1 to infinity x by 2 to power I, right? It is not iota, remember, it's not iota. So this is equal to this particular expression, which is in cos inverse, which is in brackets of cos inverse. So this is equal to sigma I is equal to 1 to infinity minus x by 2 to the power I minus sigma I is equal to 1 to infinity minus x to the power I. Now be very clear that they are not the same thing. This is minus x and this is only x. How to proceed with this? Use the idea of infinite GP over here. In what you can see, this x is between minus half and half. So its mod is less than 1, right? Mod x is less than 1, less than equal to 1, right? Even less than 1. We should say it is less than 1. As per the quotient, it is less than 1. So, and you are going till infinity. So it is the quotient of geometric progression, infinite geometric progression, sum of infinite geometric progression, right? Now how to proceed with this? What you can do, this first expression is equal to, it is x to the power 2 plus x to the power 3, and it goes on till x to the power infinity, or you say it goes on, just it goes on. Now what is the logic, what is the idea in infinite GP? A by 1 minus r, that is first term upon 1 minus common ratio. So a over here is x square, not x, be very careful. It's x square, I is equal to 1, so first term is x square upon 1 minus common ratio is x, right? Minus x into, here first term will be x by 2 and common ratio is also x by 2, right? 1 minus x by 2. Okay, fine. It is equal to, and now this is, here first term is minus x by 2, fine, and common ratio is also minus x by 2. So 1 plus x by 2. Okay, this is minus. Now here first term is not x square, it is minus x. So minus x upon 1 minus x. Again, common ratio is minus x. So 1 minus r, that is 1 minus x, 1 plus x. So let us go about this expression. It is x square by 1 minus x. You multiply x over here. So minus x square by 2 and take 2 over here. So it is 2 minus x is equal to, this is x by 1 plus x minus x, take 2 in denominator, to multiply with denominator is 2 plus x, right? Now let us take LCM over here and here as well. So taking LCM, you will get x square, take x square common, 2 minus x minus 1 plus x upon 1 minus x into 2 minus x. is equal to, take x common over here, 2 plus x minus 1 minus x upon 1 plus x into 2 plus x. Okay, so now what we can see, x is eliminated over here, x is eliminated over here as well. It is 1, it is also 1. So what we have finally, x square by 1 minus x into 2 minus x is equal to x by 1 plus x into 2 plus x. See, what you have to find? You have to find the number of solutions, number of real solutions, right? Can x be equal to 0? Can x be equal to 0? Yeah, it can be. There is no issue in this. X can be equal to 0. So, okay, yeah, x is equal to 0. It will not affect any of the expression. So, yeah, x is equal to 0 and remove this. So, there is one solution, x is equal to 0. Let us check for others as well. So, this is x, right? You have 1 minus x, 2 minus x, just cross multiply x into, this is 2, x plus 2 into x plus 1. So, x square plus 3x plus 2 is equal to, over here it will be x minus 2 into x minus 1. Right, so we have finally we have x cube plus 3x square plus 2x, and this is x square minus 3x plus 2. Simplify this, it is x cube plus 2x square plus 5x minus 2 is equal to 0. Now how to proceed with this? How to proceed with this? How to go about this? What should we do for this particular equation? How to check whether this equation has any roots or not? See, what we have, x by 1 minus x into 2 minus x is equal to 1 by 1 plus x into 2 plus x. Now we have to check whether this equation has real solutions or not. Now how to check this, whether this equation has real roots or not? For a cubic equation, either we find the roots or there is another method that differentiate this to check whether its derivative is ever equal to 0 or not. See, you differentiate this, you get 4x square plus 4x plus 5. If you think for a little, you will able to comprehend that this expression's discriminant is negative, right? Its discriminant is negative, and if its discriminant is negative, it means this is always positive, always positive. If this is a function and its derivative is always positive, what does it mean? For a function, if its derivative is always positive, it means that the function is strictly increasing. If its derivative if there is fx and you have f dash x always greater than 0, so fx is strictly increasing, and if it is strictly increasing, then what we can say for a cubic function, cubic polynomial has at least one root, 1 0, right? And it is a strictly increasing, so it will not bend, its curve will not bend. So there will be only one real root for this. So one root from this, and I hope you are getting this. This is fx. What I am saying, fx is equal to 0. We have to find the roots of this equation, and we have f dash x as always positive for all values of x. What does that mean? It means that for any value of x, for any real value of x, fx will have only one solution. See, the point is, fx will be a strictly increasing function, and a cubic polynomial or any polynomial for that matter, odd degree polynomial will have at least one real root, right? So it has only one real root, it will not bend its curve. So it has one real root. From this equation will give one root, and there will be another one for x is equal to 0. So there are two solutions for this. So answer is, number of real solutions of this equation is 2. This is the answer. This is the answer. Fine. So I hope this video was clear to each and every one of you. In case you have any doubt, please do ask and please do comment, right? And if you wish me to make any more video on any particular concept or any particular topic, question whatsoever, please do so. Please also comment for that, right? And stay tuned, keep watching our Gurukul, and we will meet in next video.